Today we're going to introduce another statistical concept, and that is the idea of working with samples. And to just get this lesson started, let's just assume that you are wanting to take a poll, and the question that you want to present to people is, since this is very appropriate since we're in a presidential election season, who would you prefer to be the next president? Would you prefer Clinton or Trump? Now, I understand that we haven't really gotten to the point where these are the nominees for each party, but I'm just throwing this out as a suggestion, just an example. Well, here's the idea behind samples. It's not feasible to think that we could ask every single person in the United States, every voter in the United States, this question. It would literally take a lot of time. It would take a lot of money. It's just, for poll people, it's just not feasible to do that. So what pollsters do is they pick a representative sample of the country, of the voting public, and they let that sample basically guide the answer to this question, okay? But the key is that it's a good representation of all voters. For example, if I only go into known Democratic locations and I ask this question, well, obviously the answer is going to lean more towards Clinton. If I go to states like some of the southern states who are known to be more Republican, and I ask this question, then obviously it's going to skew, the results are going to skew more towards Trump. And that's what we call in statistics having a sample that includes bias. So when you do polling or any kind of gathering of statistical information and it's impossible to get a response from every single person, then we use a smaller sample of the population. But it's very important that we pick a good representation of everybody so that our sample doesn't include bias toward one particular response. Okay, so today's lesson will be introducing some formulas that will help us in this sampling process. Okay, so here's just a couple of definitions I want you to have in your notes. What is a sample? Well, pretty much the technical definition from what I described on the previous slide is that it's information that's gathered from only part of the population. Remember, in most cases, these polls would be asking a question of a lot of people. I mean, you can think of every eligible voter in the United States as being the population. That's not going to be possible. It would take too long and it would be too expensive. So we can get a good response from part of the population, which is what a sample is. And again, just trying to avoid bias in our sampling. So the first formula that I want to introduce to you that you will use on the first 3 homework problems, it's a very simple one. And that is, how do we get this sample proportion? What percentage of the overall population will be included? What percentage of our population will the sample represent? And it's pretty simple. The number of times an event occurs will be the numerator. I'll describe that more on the next slide. And then the denominator will be the sample size. So you'll see in just a minute. This is going to be a pretty easy calculation. All right, so problems 1 through 3 of your assignment look a lot like this. There are 328 people out of a total of 500 teens that had never attended a popular concert. So we want to find the sample proportion for those who had never attended a concert. Okay, so this is our overall, going back to our formula, the sample size in this case is the 500 teens. Now obviously we could have polled many more than just 500, but we picked 500 as a representative sample. So the 500 is our sample size, and 328 represents the percent of those that had, or the number, I should say, of those that had never attended. So our sample proportion is literally getting this fraction in a percent form. So we take our calculator and we do 328 divided by 500, and we get 0.656. So we're going to round to the nearest percentage, and so my answer here would be 66%. So I guess you have to be careful, read the question carefully. It could be worded like this. We sampled 500 teens. This many had never attended. Well, what's the sample proportion of those who have attended? Well, obviously, that would be the difference. If we did 500 minus 328, then that's 172. If 328 never attended, then 172 have attended. So just be careful that you read the question carefully. If it had turned to how many, what's the percent of those who have attended, then we would be doing 172 over 500. Okay, so I just wanted you to give you a heads up here. Just make sure you read the question carefully. But the denominator will always be the total sample size. The numerator should always be smaller. Okay, and if you'll read the question carefully, I don't think you'll have any trouble with the first 3 problems on your assignment. I just threw this out at you because we're about to introduce another statistical concept called margin of error, or I just refer to it as MO. And during this election season, you're going to see a lot of polls. If you watch TV, or if you even look at social media, there are a lot of polling data that's coming up over which candidate is preferred over another. Well, this, you can't really see this real well. It's kind of chopped off, but this is an old, it's just basically a poll over Obama's job approval rating. Now, I'm not trying to, for you Obama fans, I'm not trying to point out, about his bad job, good job, or anything else. This is just to use this as an illustration of what margin of error. I want you to be on the lookout, now that we're in this presidential election season, for these polls that contain margin of error. And what does that mean? Well, it basically comes from the fact of we're not asking every single person who's eligible to vote a question on, do you approve or disapprove of Obama? Okay, again, that's impossible to do. It's not feasible. So we're going to pick a sample, and we're hopefully going to pick a good representation of everybody that's eligible to vote. Well, because we're only picking a sample, there's some error involved. It's not an exact science. And in general, the smaller the sample, the larger the margin of error. So good polling people will try to increase, they'll try to ask a pretty large sample of the population, try to get as many people as they can. In this case, 1,500 people were asked this question. And so that includes, since 1,500 people out of the whole population were asked, then there's some built-in error, anywhere from positive 3% to negative 3%. So I just wanted to point this out to you because on the next slide, we're actually going to be calculating margin of error for a sample. And so again, there's another formula. There's quite a few formulas that you're going to be using in chapter 12, and here is our margin of error formula. I just call it MO. It's equal to plus minus. Remember, our margin of error over here was a range of anywhere from positive 3 to negative 3%. So don't forget, for margin of error, it's a range. It's going to be plus minus 1 over the square root of whatever the sample size is. So this is a pretty easy calculation. On problems 9 through 11, you're going to do basically this. Let's take letter A, for example. If I have a sample size of 500 people, then my margin of error will be calculated by doing plus minus 1 over the square root of 500. Okay, so let's grab your calculator and let's do that. 1 divided by, and then in the denominator, we're going to do the square root of 500. And that's the decimal form. And we're going to, again, we're going to round this to the nearest tenth. So if we change that to percent by sliding the decimal 2 places to the right and round to the nearest tenth, we get plus minus 4.5%. Okay, now let's increase the sample size, and let's do the MO for a sample size of 1,400. So once again, margin of error will be calculated by doing plus minus 1 over the square root of 1,400. Okay, let's find out what that is. 1 divided by square root 1,400. Okay, notice as our sample got bigger, our margin of error went down. Okay, and that probably makes sense to you. Rounded to the nearest tenth, this should be about 2.7% plus minus. Okay, so the more people we ask, the smaller their range of margin of error becomes. If we ask fewer people, then that's going to include a higher margin of error, a little less reliable as far as the results that we can conclude. Okay, so that's your margin of error formula. You're going to practice that 3 times in problems 9 through 11. Okay, 12 through 14, we're still dealing with the margin of error formula, but this time notice they're going to give you margin of error, and you're going to have to find the resulting sample size, or in other words, you're going to solve for n. Okay, so let's just take a look at letter A. If the margin of error is plus minus 6%, I'm just going to write that as a decimal. Okay, plus minus 6%. And I'm solving for n. Okay, well really sample size is not going to be a negative number. We're not talking about a negative number of people. So really, if you want to, you can just think of this as just a positive number. All right, when you're solving for a sample size, you're always finding a positive number. Well, you got a couple of ways of looking at this. Solving for n, you might want to consider just flipping, since n is in the denominator, you might want to just consider flipping both of these over, maybe raising both sides to the -1. You know, the effect of raising anything to the -1 power. Well, that just flips it over, so instead of 0.06, it's 1 over 0.06. And flipping this fraction over, you get the square root of n. Okay, so how do we solve for n? Well, that's pretty easy. We've covered this before. We just do the square root of both sides. And so my answer is going to be, or not the square root of both sides, squaring both sides. My answer is literally in my calculator, I'm going to do 1 divided by 0.06. And I'm just going to use parentheses around that. 1 divided by 0.06, close parentheses. And then I'm going to just raise that to the second power. Okay, and since we're talking about people generally in these sample sizes, I don't like to represent people in fractions. So for when you're finding a sample size, you should always round to the nearest whole. All right, so my calculator is showing 277.777 and so on, but to the nearest whole person, I get a sample size of 278. All right, so let's try this one, letter B. If the margin of error is plus minus 11%, well, remember, since we're dealing with positive numbers here, I'm just going to ignore the negative, and we're going to solve for n. And I'm showing you algebraically how this would happen. So I'm going to flip 11% over and make it 1 over 11%. And that means I can flip this fraction over and make it the square root of n. So the way I'm going to get n, once again, is I'm going to square both sides. All right, so grab your calculator. 1 divided by 0.11 squared. And that is 82.644621, but we need to round this to the nearest person. So we're going to say that our sample size is 83. Okay, so notice for a margin of error that gets bigger, our sample size is smaller, and that's illustrated over here. As the margin of error shrunk, we have more people in our sample size. Okay, almost done. This will wrap it up. Find the margin of error for the sample. Okay, so we've done that. And then find an interval likely to contain the true population proportion. So here is my situation. I surveyed 528 students, and those students said that 65% already had plans after high school. Okay, so let's hold on to this 65% number. Let's first find out what is the margin of error for a sample size of 528 students. Okay, so margin of error, again, we used this earlier, is equal to plus minus 1 over the square root of, in this case, 528. Okay, grab your calculator. 1 divided by square root 528, and I'm showing 0.0435. So we're going to round to the nearest tenth, and I'm going to call that plus minus 4.4%. Okay, that is my margin of error. And, you know, to make this math a little bit easier, I'm just going to tell you in these problems, you can just round to the nearest percent. I think that'll be okay. Let me take a quick look at how the book is. Yeah, the book is rounding to the nearest percent. So I'm going to say you can do the same thing. All right. So that's our margin of error approximated to the nearest percent. Well, now, if the margin of error is plus minus 4% and 65% said that they had plans after high school, well, building the margin of error in, that's going to create a range, okay? If you think of it this way, here's 65% that said they do have plans, but there's a built-in margin of error. So that means if we subtract 4% from 65%, we get 61%. And if we add, remember it's a range of plus minus, if we add 4%, then we get 69%. So the answer, the interval, okay, we found the MO, that's plus minus 4%. The interval likely to contain this true population proportion, accounting for the margin of error, is the range 61% to, I'll just put it this way, 61% to 69%. Okay, so basically you're finding MO based on the given population sample, and then whatever MO is, you're going to subtract and add to the given percentage of people that responded a certain way, and that will create a, I call it a range. The book is using the word interval. Okay, so this would be my answer to this question. All right, I think I've given you enough. This is your assignment. Make sure that you take notes carefully, because that will also be checked as part of your homework along with these problems. And just email me if you have any questions.